For centuries, mankind has gazed at the night sky, filled with questions about the enigmas of the universe. In the 20th century, scientists proposed a theory we know today as the Big Bang Theory. This theory struggled to answer crucial questions about the origin, development, and expansion of the universe. However, recent research has added even more complexity to this mystery. In 2023, NASA's James Telescope made an astonishing discovery. It detected celestial objects that were apparently older than the universe itself. This revelation has left scientists baffled and questioning the possibility that a star could exist for a period of time longer than the universe itself. Does this call into question our current understanding of the cosmos? Might it require the conception of a new model to give meaning to this enigma? These questions and many more will be answered in this video. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. About 200 light years away, near the constellation Libra, lies an ancient star known as HD 1140283. The surprisingly high velocity of the star HD 1140283 at 44,283 kilometers per hour gives us valuable clues about its dramatic history about 1 billion years ago. At that time, our Milky Way, in the process of formation, merged with a dwarf galaxy that served its home. However, the most amazing thing about HD 1140283 is not its speed, but its age. The star is among the oldest celestial objects we have had the privilege of observing and has been nicknamed Methuselah, in reference to the biblical character who, according to the legend, lived 969 years. Initially, estimates placed its age at a staggering 16 billion years, but the most recent estimate placed it at 14.46 billion years, with a margin of error of 800 million years. This figure poses a considerable conundrum, as a contrast with the age of the universe as we determine it through observations of the cosmic microwave background, which stands at approximately 13.8 billion years. The question arises as to how a star can be older than the universe itself, which seems to be impossible to the naked eye. This paradox has raised questions regarding the age of the star, the accuracy of our dating methods, and ultimately the actual age of the universe, inviting further exploration of these cosmic mysteries. First, it is critical to understand that calculating the age of celestial objects represents a considerably complicated task. Stars, like our own sun, maintain their temperature and size unchanged for billions of years, which makes estimating their age extremely difficult. Astronomers rely on subtle changes in the brightness and color of the stars over time, and then compare these measurements to mathematical models that predict how these stars evolve. A crucial indicator for determining the age of a star is in its rotation rate over time. Stars slow down, similar to a wheel slowing down due to friction. By comparing the rotation rates of stars of different ages, astronomers have established mathematical relationships that allow them to estimate their ages, using a method called gyrochronology. The star Methuselah is indeed ancient. In fact, it is the oldest star in the universe with an age that we can estimate reasonably accurately. Instead of wondering whether it might be more than 2 billion years older than its surroundings, we can approach the problem from a different perspective. Is it possible that the universe is not as young as scientists initially believed? Indeed, it is difficult to comprehend the immensity of 13.8 billion years if we try to summarize the entire history of the universe in a cosmic calendar, where the Big Bang would be equivalent to the most dazzling New Year's fireworks. The Earth, in this escalation, would only join this cosmic celebration at the end of the year, while recorded human history barely spans the last 10 seconds of December 31st. Scientists determine the age of the universe by observing the light from stars that were born hundreds of millions of years after the Big Bang, as the universe expands, causing a phenomenon known as the redshift. When we evaluate both the observable distance and the universal expansion, a universal age of approximately 13.8 billion years is deducted. However, recent discoveries by researchers at the University of Ottawa raised the possibility that the universe is significantly older, estimated to be about 26.7 billion years old. University of Ottawa physicist Professor Rajendra Gupta presents a theory that merges Swiss astronomer Fritz Zwick's 1929 theory with novel ideas. This theory suggests that protons lose energy during their journey over vast distances and times, despite being in contradiction with observable data related to redshift. Gupta proposes that by allowing this theory to coexist with the expansion of the universe, we could reinterpret the redshift as a hybrid phenomenon that is not exclusively due to the expansion. This reinterpretation would increase the estimate of the age of the universe and could offer explanations for long-standing cosmological questions, as well as some recently raised by NASA. NASA's James Space Telescope has been instrumental in arriving at this estimate of 26.7 billion years. Gupta combines the tired light theory with the concept of evolutionary interaction constant, originally proposed by theoretical physicist Paul Dewar, implying that interactions could have undergone changes over time. It is relevant to note that scientists have previously revised the age of the universe on different occasions. For example, in the 1920s, Edwin Hubble claimed that the universe was only 2 billion years old. However, over time, our estimates have improved significantly, doubling the age of the universe. This increase represents an important milestone as astronomers strengthen their understanding of the age of the universe, reached in Gupta's work. Regardless of whether we consider the recorded history of humankind to be equivalent to only 10 seconds or 5 seconds in the immense time frame of the universe, what is undeniable is that the universe is an extremely old and amazing place. Its constant expansion leads us away from previous notions about its age. However, there are also remarkable observations concerning our own galaxy, the Milky Way. Recent measurements suggest that stars in the outer regions of our galaxy move at a much slower rate compared to stars in similar locations. This raises a couple of possible explanations for this phenomenon. One is that our galaxy may possess an exceptionally low amount of dark matter, an invisible substance that plays a crucial role in the gravitational structure of cosmic objects. The other possibility is that our understanding of dark matter, including how much of it exists in the universe, may be mainly different from what we have considered so far. This conundrum originates from data collected by the European Space Agency satellite, which provides detailed information about the positions of nearly 2 billion stars in the Milky Way. These data have led astronomers to reconsider their assessments of stellar behavior, particularly in relation to stars in the outer part of our galaxy. The speed at which stars move is an essential indicator for estimating the mass of a galaxy, since the gravitational force affecting each star depends on the total mass of the galaxy. A recent study, based on data collected by the Gaia satellite, calculated that the combined mass of our galaxy, which includes gas, dust, stars, and dark matter, is approximately 200,000 billion times the mass of our Sun. And although this figure is considerable, it is about 5 times less than previous estimates. This is due to the fact that the amount of visible material in the Milky Way has not inexplicably decreased. A suggestive interpretation of this result is that there are maybe less dark matter than previously considered. However, measuring the mass of a galaxy is a notoriously complicated task, raising the possibility of uncertainties in the data collected by the Gaia satellite or in the new analyses that have been developed. The James Webb Space Telescope has transformed our view of the universe. The images obtained by this large infrared-capable telescope have caused a sensation around the globe and have been shared on a massive scale. It is safe to say that the James Webb is the most advanced telescope in the history of humankind. So far, the scientific observations made by the James Webb Space Telescope have been invaluable and fully justify the $10 billion invested in its construction. The first images from the telescope were released to the world on July 12, 2022, and experts believe they showed that James Webb is at its best and fully prepared to continue uncovering the secrets of the infrared universe. These images include the cosmic clefts in the Carina Nebula, the exoplanet WSP-96b, the South Ring Nebula, Stephanie's Quintet, and the stunning deep field view of the universe. Although these were only the first images, Since then, the James Webb Telescope has provided scientists with even more spectacular and stunning images of the cosmos. Some of these images have perplexed astronomers and cosmologists, and have led to the publication of many astronomical articles. However, some of these papers have generated some panic among cosmologists because they seem to directly contradict the Big Bang theory. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. To better understand what is going on, it is necessary to first understand what exactly the Big Bang theory is. The Big Bang is the predominant cosmological model that explains the evolution of the observable universe. It was developed from observations of the structure of the universe and theoretical considerations, and explains how the universe expanded from an initial state of high density and temperature. The Big Bang theory describes an increasingly concentrated universe originating from a singularity in which space and time lose their conventional meaning. Based on detailed measurements of the expansion rate of the universe, the Big Bang singularity is estimated to have occurred about 13.787, more or less 0.02 billion years ago, which is also approximately the age of the universe. Although the concept of the Big Bang may seem confusing, it is actually quite simple. The universe is continuously expanding, and the name Big Bang can be misleading, as it suggests that there was an explosion at a particular time and place with a center. However, the universe has no definite center, and the Big Bang occurred everywhere at the same time. This process occurred over time, not a specific point, and galaxies are moving away from each other without a definite center. Although we cannot directly observe the Big Bang, there is observable evidence for it. For example, the heat that was generated about 380,000 years after the Big Bang can be detected throughout the universe, which has been mapped by satellites such as the Carnot Background Explorer, World Ends Microwave and Isotropy Probe and Planck. During this period, the universe was very smooth and simple, with small temperature ripples. The James Webb Space Telescope, designed to image the first object that formed as the universe began to cool after the Big Bang, has seen further than the Cosmic Background Explorer Telescope or Professor Michael Webb and Professor Blanco's story. Dr. Mather, who is the lead scientist of the James Webb Telescope project, claims that this telescope could image objects that formed hundreds of millions of years after the time period that other satellites were built to see. The small changes in temperature observed by those satellites may have been the seeds that eventually became new galaxies. Although we do not know exactly how and when the first stars and galaxies formed in the universe, the James Webb Telescope was built for the purpose of answering this question. In summary, the Big Bang theory is the primary explanation of how the universe began. This theory indicates that the universe began as a hot, dense point that inflated and stretched at initially unimaginable speeds, and then at a measurable rate. Over the past 13.8 billion years from the Big Bang to the expanding universe we see today, the Big Bang theory has been widely accepted as the most likely explanation for the origins of the universe. However, new images from the James Webb Telescope are causing some uncertainty among some scientists about the credibility of this theory. Most cosmology theorists have defended the Big Bang theory as unquestioned truth for decades. But new data from the telescope are causing some people, like Alison Paltic, an astronomer at the University of Kansas in Lawrence, to question everything they have done in this field. The extremely small, smooth, ancient, and surprisingly numerous galaxies observed are completely incompatible with the Big Bang hypothesis. In the view of some scientists, the Big Bang proposes that the universe is expanding, and that galaxies and other objects in expanding space should appear larger with increasing distance. However, images from the James Webb Telescope shows us more and more smaller galaxies, even those with a luminosity and mass much greater than that of the Milky Way, suggesting that the universe is not expanding and that the redshift is proportional to the distance of galaxies. In other words, the galaxies shown by the James Webb Telescope are the same size as the galaxies near us, indicating that the universe is not expanding. The images obtained showed that the galaxies have a redshift that is 2 to 3 times larger than expected according to the theory of an expanding universe, which contradicts this theory but aligns with the prediction of a non-expanding universe.
Previous results based on Hubble Space Telescope images showed a redshift of up to 5, which agreed with expectations of an ordinary non-expanding space. Big Bang proponents expected to see galaxies chaotic and destroyed by collisions and mergers, but the James Webb Telescope images show smooth disks and ordered spiral shapes similar to present-day galaxies. According to Eric Lerner and Ricardo Scarpa, these findings challenge the theory of an expanding universe. The data in the panic paper indicate that there are many more smooth spiral galaxies than expected, challenging the idea that galaxies have a common formation process. Lerner and Scarpa argue that these data completely discredit the theory of galaxy formation. Furthermore, the Big Bang theory suggests that the most distant galaxies in the James Webb Telescope images look as they did 400 to 500 million years after the origin of the universe. But some of these galaxies have stellar populations that are at least a billion years old. According to the Big Bang theory, nothing could have originated before, which leads to the author of Panic to believe that the existence of these galaxies is proof that the Big Bang did not occur. In a study to be published in April in Monthly Notices of the Royal Astronomical Society, the researchers analyzed in detail a cluster of nearly extinct stars of enormous antiquity called HB1. The extraordinary cluster lies about 21,500 light-years from Earth, in the central bulge of stars at the center of the Milky Way. They are true fossils that revealed what the early days of the universe were like. First generations of stars formed when the only available material was hydrogen and whose age rivals that of the universe that contains them. And now, to the general surprise, a team of astronomers has found some of them within our galaxy. To observe it, it has been necessary to combine the power of two large telescopes, Gemini South in Chile and the Hubble Space Telescope. Thanks to the sum of their data, the researchers were able to calculate the age of the stars in the cluster, which turned out to be 12.8 billion years old, which includes them in the group of the oldest ever found in both our galaxy and in the universe in general. This cluster of stars, says Stefano Sousa, co-author of the research, is like an ancient fossil buried deep in the central bulge of our galaxy, and we have now been able to date it to a distant time when the universe was still very young. These are also some of the oldest stars we've seen anywhere else. Astronomers have made a surprising discovery using the James Webb Space Telescope. They have identified the most distant globular clusters ever seen. These clusters are composed of millions of stars and could be the remnants of the first stars to form in the universe. What did James Webb Space Telescope just discover? And how would this discovery impact everything? Stay tuned as we bring you this fascinating discovery by the James Webb. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. The first science quality image taken from NASA's new Webb Space Telescope revealed a fascinating distant galaxy surrounded by dense clusters. These clusters may contain some of the earliest stars in the universe and are located at a distance of 9 billion light-years from Earth. The team of Canadian astronomers focuses on the Sparkler, or Spark Galaxy, because of the unusual appearance of its stretched shape and the compact subjects surrounding it, which look like small reddish-yellow blobs. The galaxy is notable for its unusual stretched appearance, but the surrounding objects that inspired the nickname are of considerable scientific importance, as they may be the most distant globular star clusters ever discovered by astronomers. But what are these globular clusters? Globular clusters are groups of ancient stars that have been present since the formation of the galaxy in which they are found. They are important because they can provide information about the earliest stages of galactic evolution. A team of scientists from Canada has examined the compact objects surrounding the Sparkler galaxy and found that 5 of them are globular clusters. These clusters may be the oldest ever observed and maybe have existed since the earliest times in the universe. Study co-lead author Karthik G. Lier said it was surprising to find such a unique object so early in the James Webb Space Telescope data, and that most of the flares around the main body of the galaxy are truly massive and ancient stellar systems. This discovery has the potential to provide valuable information about the evolution of the universe and how galaxies and stars formed. According to Lier,
Thanks to the James Webb Space Telescope image, the team was able to study the sparks at different wavelengths, allowing them to accurately model globular clusters to learn more about their physical characteristics, such as their age and the number of stars they contain. Before the James Webb Space Telescope, it was impossible to date the first stars in distant early galaxies using distant globular clusters. In an interview, study co-author Lamia Molla, an astronomer at the University of Toronto, explained that the goal is to date all objects in the universe, including stars, galaxies, and globular clusters, and to find out when stars began to be born. It is currently believed that there are 150 globular clusters in the Milky Way, although their age is unknown. The discovery of distant and ancient globular clusters could provide valuable clues about the early formation of the universe and help solve some of the biggest mysteries in astrophysics. Compared to younger objects in our galaxy, older globular clusters are more difficult to date and determine their age. The Sparkler galaxy, seen as it was 9 billion years ago, is easier to date because the globular clusters around it appear younger at that time. It's like looking at a picture of a baby instead of a picture of an adult to estimate their age. According to astronomer Molla, it is easier to determine the age of a 1-year-old child than the age of a 50 or 55-year-old adult. Astronomers use data from the James Webb Space Telescope (NIRISS) to confirm the age of globular clusters in the Sparkler galaxy. NIRISS detected no oxygen, which is common in young clusters that are in the midst of star formation. To observe the galaxy, James Webb Space Telescope was aided by the Hubble Space Telescope and a phenomenon known as gravitational lensing, which is a useful tool for astronomers thanks to Einstein's general theory of relativity. According to this theory, massive objects bend space-time, which affects the path of light through space, like placing balls of dust on a stretched rubber sheet that becomes more dented the greater the mass present. Nearby objects acting as gravitational lenses can distort and magnify the image of the background object, making it appear much larger. In the case of Sparkler Galaxy, the gravitational lensing of the SMACS 0723 galaxy cluster distorts its shape and magnifies it enough for the James Webb Telescope to detect it. In addition, some of the surrounding clusters appear to be in multiple locations in the image due to its effect. This observation confirms that the clusters do indeed orbit around the Sparkler Galaxy. However, astronomers still do not know precisely how much the SMACS 0723 cluster amplifies the image of the galaxy, so they plan to build a better magnification model to get a more accurate estimate. If the magnification of the Sparkler Galaxy and its clusters can be understood, more precise information about their age and distance from Earth can be obtained. For this reason, the CONEX team will use the James Webb Space Telescope to investigate 5 giant galaxy clusters in the hope of discovering systems similar to the Sparkler Galaxy. The expectation is that the James Webb Space Telescope ability to observe globular clusters at great distances will encourage more research and searches for similar objects in the future. Astronomers also plan to use the James Webb Space Telescope to investigate distant globular clusters to better understand their evolution. There are 2 main theories about the formation of these objects. One suggests that they are formed during the cosmic dawn, when the universe was in its early stages of star and galaxy formation, while the other theory posits that globular clusters formed mainly during the cosmic midday, when most stars and galaxies were forming. This discovery has had a major impact in our understanding of the universe and has prompted NASA to develop even more powerful telescope than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb's F spectrometer and near-infrared camera have revealed that 4 of the 6 primary galaxies have extreme redshifts, suggesting that Webb is observing them as if they existed 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our understanding of the early universe. This has generated concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, which has some loopholes, such as going against the law of thermodynamics and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything we thought we knew about the origins of the universe. According to theoretical physicist Michio Kaku, the discovery of ancient galaxies by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. Previously, these galaxies were thought to be less developed than the Milky Way, but new findings suggest that we may be missing crucial information. The fact that the telescope has identified 6 galaxies that existed 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises the question of whether our current theories about the creation of the universe are correct. Kaku explained that it takes billions of years to create a galaxy like the Milky Way, so it is strange to find such large, young primordial galaxies. This discovery may require us to revise and rewrite textbooks on the beginning of the universe. The James Webb Telescope findings challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another intriguing piece to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow in size and become something similar to the colossal Coma A1656 cluster. The place where all this is taking place is unique and special, as it is in an area of accelerating galactic evolution thanks to the James Webb Telescope. Now researchers can measure the velocity of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a proto-cluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers that will eventually join together to form a large and powerful river. Clearly, what we once believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows? Maybe the Big Bang did happen, but what caused it is a different story. In any case, we will have to wait for more discoveries, but the answer may be closer than we think. What do you think about the discoveries? Share your thoughts in the comments box, and I'll see you in the next video.